Number 15, almost done with the final exam from spring 2012. We're given information about a vase starting from rest, rolling down a certain distance on a 14-degree incline. Speed at the base of the bottom is given. We want to determine mass moment of inertia of the base. Okay. So we could work this a couple different ways. Usually conservation of energy and constant acceleration. If I have my choice, I'm always going to use conservation of energy, as long as it doesn't require any sort of information about time, which this one does not. So let's look at conservation of energy. We're going to have our incline here. Okay, 14 degrees. We're going to have our vase up here. We'll call this state 1. Its velocity equals 0. Okay, we'll have it down here at state 2. Its velocity was 2.1. Okay, the distance it rolled was 1.6 meters. Okay, and we're given some information about the mass, 0.6. Okay, mass of 0.6 kilograms and a radius of 0.2 meters. Okay, and we said conservation of energy. So all we have here is kinetic and potential energy. We're going to use the bottom as our datum. Here is our H. Okay, we're given information to calculate H is 1.6 sine 14, so we'll go ahead and do that. Okay. .387. Okay, so there's our datum. So we'll have, I'll write it in general terms first. And the key concept we want here, it starts from rest, so no kinetic energy initially. And the key concept here is we have two types of kinetic energy. Translational, 1/2 mv squared, and rotational, 1/2 I omega squared. Okay, so there's I. That's what we're solving for. So let's plug in some other values here. Let's see, mgh 0.6, 9.81, 0.387 is equal to 1/2 0.6, 2.1 squared. Everything's in meters, seconds, and kilograms, so our units will work out here. And my other term is going to be 1/2 I omega, we know is V over R. Okay, I can actually calculate that number 0.2. So omega is 2.1 divided by 10.5 radians per second. Okay, and I will write this out right here. 1/2 I 10.5 squared. And we can solve for I. Let's see, we can get that all on the calculator here. 0.6 times 9.81 times 0.387. 2.27 was that number, minus 0.5 times 0.6 times 2.1 squared. Okay, times 2 divided by 10.5 squared. 0.0173. Alright, let's talk about units for a second. Okay, if I write my units out, kilograms, come on, I had a different color there. Kilograms, meters per second squared, and H was meters. So every term in here should be kilograms meters squared over second squared. Alright, so let's check this one. This was mass, and that was meters squared over second squared because V squared. Okay, and this is going to be radians per second squared. Radians is unitless, so this is going to be 1 over second squared. Alright, so I is going to be, here's second squared in each of these terms on the bottom, so I is going to be kilograms meters squared, which we know that is correct units, mass and distance squared. 0.017 3 kilogram meters squared. Alright, enough of that.